Hello everyone and welcome. In this video, we'll be looking at how to add floating point numbers. Again, our examples would have 10-bit mantissa and a 6-bit exponent. Before I look at a typical example, I want to remind you of something you would normally do in maths. So let's say, for example, in maths, you were asked to add 1.234 to 123.4. If you were asked to do this, one thing you may do is to align the decimal point. So you might say 1.234 and then align the decimal point so you have 0.4 there, and then 1, 2, 3. So if we add these two numbers together, we would have 436.421. So 124.634. So that's what you would have. So let's see how you will do this with floating point numbers. So in our example, we're going to add not 1, 1, 3, 4, 5, 6, 7, 8, 9, 10. So that's our 10-bit mantissa, and the exponent for this value here is 1, 2, 3, 4, 1, 1. So a 10-bit mantissa and a 6-bit exponent. And we're going to add this to another value, which is 1, not 1, not 1, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's a 10-bit mantissa for the second value, and the exponent for that value is not 1 as a 6-bit exponent for it. So looking at these values, I know that that is a positive mantissa and that is a positive exponent, and for the second value here, that is a positive mantissa because it begins with 0, and that is a positive exponent again because it begins with a 0. So really there is no need for me to represent any of these values in its 2's complement form. The next thing I would have to do is to find the value of our exponents. So the value of this exponent here is 1 and 2, which is 3. So technically this exponent here is 3. So we're looking at 2 to the power 3. The value of this exponent here is 1. So we're looking at, for this exponent, 2 to the power 1. Now remember, when we looked at normalization, if you've not seen the video, I've posted it separately. But when we looked at normalization, we highlighted the fact that our mantissa would always have a decimal point here. Would always have a decimal point here. So technically speaking, the values we have here, we have, if I write it down again, we have not 1, 1, not 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have that decimal point here, or sorry, the radix point here, times 2 to the power 3 plus 0.1, not 1, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times 2 to the power 1. Now, because this is a positive value 3, and that is also positive, it means we would have to shift our decimal point, our radix point there, to 3 places to the right, and for this one to 1 place to the right. It's going to the right because it's a positive value. So with a positive 3 there, our exponent will be 1, the value will then be 1, 2, and 3. And for this one, I'm just going to shift it to the right one time, which means our point will be up there. So, going back to what we did here, what I'm going to do now is I'll write down this number showing where the new radix point is. So the number I have there is 0.110.1234561, 1234561 plus. Now for this one, I'm going to align my decimal point. So I have my point there, and I have 1 0 there, and just after my radix point I have 0 1 1, and then I have 5 zeros afterwards. Okay, I keep interchanging the radix point with decimal point. It's just habit. Well, because we're working with binary values, it should be radix point. Radix spelled RADIX point. So we've aligned our decimal point, or our radix point, and we're now just simply going to add the values now. So to add the values, I would have 0 0 0 0 0 1 1 0.1110. Okay, so remember, I would have recurring zeros in front there. So this is our answer when we add both values together. If in the exam you are then asked to normalize, so please make sure you watch my video on normalization, or if you don't understand normalization, you can find other resources that will teach you how to normalize values. If you're asked to then normalize this answer now, because our answer, I can see here, has a recurring zero, it's going to definitely have recurring zeros in front there. It means that I would have to move my decimal point 3 places to the left. Okay, I'd have to move my decimal point 3 places to the left, and then you normalize in that way. Okay, in this case we will then have 1 2 and 3. I'll stop, which will give me, using a 10-bit mantissa, I would have 0 1 1 1 0 1 1 1 2 3 4 5 6 7 8 9 10. So this will be my answer as a 10-bit mantissa. Remember, it is now times 2 to the power 3, and 3 as an exponent is 0 0 0 0 1 1. That's the final answer.